Hello, this is Dr. Amudapriya, Associate Professor Triply from Rohini College of Engineering and Technology, Palkulam. We are discussing about the course Power System Operation and Control, and in this lecture we will discuss about the unit commitment problem. So what is unit commitment? In order to find the least cost dispatch of available generation resources to meet an estimated electric power demand over a given time horizon is known as a unit commitment. So with a given load profile and with a given set of units available, when should each unit be started, stopped, and how much it should generate to meet the load at a minimum cost. So economic dispatch problem will deal with how many number of units has to be operated at that particular time. That is the thing. But in unit commitment, it is purely based on the minimum cost. For example, let us consider three different units for which the active power minimum maximum value and the cost objective function are being given. So at what combination of the three units has to produce 550 megawatt at a minimum cost? This is the question. And how much should each unit in that combination has to generate? So what you have to do? Far too few units have to be committed. So we can't meet the demand if we are using few units. Not enough units are being committed means at that time also some units have to operate above its optimum. If too many units are committed, then some units will be operated below its optimum value. And if suppose far too many units are being committed, minimum generation will be exceeding the demand. So in such a case, and on no load cost will affect the choice of optimal combination. So these are some of the things. Now let us consider the load demand as such. So the unit constraints which we have to consider for drafting the unit commitment problem statement is the maximum generation capacity, the minimum stable generation, minimum uptime, minimum downtime, and the ramp rate. So with this we can have the minimum uptime as once the unit is been running, it may not be shut down immediately. And similarly, minimum downtime is the case when once the unit has been shut down, it may not be started immediately. With that condition, we go with the up and down time. And next, while considering the ramp rates, if it is a maximum ramp rate or a maximum ramp rates ramp up rate or ramp down rate constraint, it has to avoid the damage of the turbine. It should not damage the turbine. The electrical output of a unit cannot be changed by more than a certain amount because it will create vibration and there will be deflections in the output. So the next is the system constraints. So what are the system constraints? The constraints that affect more than one unit are the load or generation balance, reserve generation capacity, emission constraints, network constraints, etc. And regarding the types of reserve, there may be spinning reserve which will be primary or secondary. Primary will be acting quickly with respect to the changes, and secondary will be operated at a time, with the time delay after the primary is getting terminated. Or there may be certain conditions where the secondary have to be operated along with the primary, but not immediately with the primary. So it will have a slower response. Next is the tertiary reserve. It will be replacing the primary and the secondary reserve to protect against another outage. So it is provided by the units that can start quickly, like open cycle gas turbines, also called the scheduled or offline reserve. So with the different types of reserve like positive reserve which increases the output when the generation is less than the load, and with the negative reserve for which the decrease output when generation, it will decrease the output when generation is greater than the load. Also the other sources of reserve are the pumped hydro plants, demand reduction, and the reserve which must be spread over the network, must be able to deploy the reserve even if the network condition is congested. These are the different types of reserve which you have to consider. So all these reserve will incur the cost. So the reserve cost, even when it is being not called more number of units scheduled than the required unit means those units which are not operated at that maximum efficiency will lead to an extra startup cost. So, it must build a certain unit which is capable of rapid response. That cost of reserve should be proportionally larger in smaller systems. Important driver for the creation of the interconnections between the systems will lead to this cost of reserve. And while considering the environmental constraints, scheduling of generating units, for example, if it is been subjected to pollutants like SO2, NOx, etc., then there are various forms of constraints like there should be limit on each plant at each hour, then limit on plant over a year, limit on a group of plants over a year, etc. Also protection of wildlife, navigation, recreation has to be considered while considering the hydro generation. All these constraints together with the cost optimal objective function will put up upon the minimum cost optimization in case of unit commitment.